These 4 problems will review some of the factoring rules that we have. The first one takes into account a couple of them. The first thing is the GCF. You must look for the greatest common factor in any factoring problem first. If you forget to look for it, it not only will get you an incomplete answer, but it could cause you to not know how to factor the problem because it won't look right. So here, the GCF is 4, and so let's take that out right away. And that leaves me with x squared minus 25 on the inside. Now, anytime you take the GCF out, or for that matter, anytime you factor anything, you should always look at the factors left over and see if what you have left is still factorable. And x squared minus 25 is factorable. It's one of your factoring patterns. It's the difference of 2 squares. And the difference of 2 squares is recognizable if the first term is a square, and it is, its root is x. The second term is a square, it is, its root is 5, and then that you actually have a problem that's a difference. A lot of people mess up when they see x squared plus 25 and factor this the same way, but it's got to be minus, that's why it's a difference of 2 squares. So now when I factor this, the first thing you also have to remember is to keep bringing the 4 along with it. Just because the 4 has already been factored out doesn't mean it disappears in the next step. So it's 4 times, and then difference of 2 squares follows the same pattern every time. Just take the 2 roots and make one x minus 5 and the other x plus 5. So whatever the 2 roots happen to be, it's always adding them and then subtracting them in order. And then this would be your final answer. You can also check factoring just like you can do some of the other problems that I've showed you on the calculator. By using the store command, because again these things should be equivalent expressions. So if you pick a number for x, and remember, don't use 1, 0, or negative 1, because those things could make expressions seem the same, but it might only be because of a special case of those numbers. So let's store 3 into x, and then I'll type in 4x squared minus 100, and that'll give me negative 64, and then I'll type in my other expression, and notice I get the same answer. You can work backwards from the answers on a multiple choice test, so this is a pretty powerful tool to keep in mind. Now let's go to x cubed minus 8. X cubed minus 8 looks like difference of 2 squares, except they're not squares, these are cubes. And so that has a root of x, and that has a root of 2. And the pattern for difference of 2 cubes is, you look at the roots, in the first parenthesis, first root, steal the sign from between here, so if it's minus, this is minus, and then take the second root. So the x minus 2 came directly from here, x minus 2. The next parenthesis, square the first root, so x squared. Change the sign, so since this was minus, this was going to be plus. If this started out as x cubed plus 8, this would be minus. Multiply these two together, so 2x, and then always add the third root, whether this is minus or plus, this will always be plus, and then square the third one. And so we're done. Alright, the only difference if this was plus, this would be a plus, that would be a minus. Okay. The third type, this is going to be called factoring by grouping. We still have to look for a GCF, but there clearly is not one. The last term doesn't have an x, and 3, 2, 9, and 6 don't share any factors other than 1. So when you have 4 terms, basically what we're looking for is factoring by grouping. Okay, and so when you do factoring by grouping, the first thing you're going to do is you're going to wrap parentheses around the first two and the last two. But here we have to be very careful. Because when I wrap parentheses around the last two things here, notice that with this minus sign, that's going to affect things. So if I were to just go like this minus sign now changes things, because even though the minus times the 9x is going to get us the negative 9x we want, the minus 9x plus 6 is going to get us a minus 6, but that needs to be a plus 6. So you have one of two options. Either you can change the sign inside to make sure that the signs remain the same, or some people find it just easier to put a plus sign up front and then store the negative sign inside there. The key thing is that when you're doing the grouping, the factors need to match, so you're going to end up factoring that first negative sign out all the time anyway. So it depends on which way you like doing it better. I'll leave it this way for right now just so I can show you factoring the negative sign out. So in each parenthesis there should be a GCF. So in this case the GCF is x squared. So I'll take out the x squared. And then here the greatest common factor is 3, but I'm going to pull out the negative 3. So and that's going to leave me with 3x minus 2 as well. The one thing that you want to make sure of when you're done is that those two parentheses are exactly the same. If not, don't ignore it or just say, well, I'll just change the sign because I made a mistake. Realize back here that there could have been sign trouble, and make sure you fix it in one of the two ways that I showed you. Okay, at this point, if you think of it, 3x minus 2 has now become a common factor. A factor is just anything that's multiplied together. So x squared times 3x minus 2 makes each of them a factor. And so now I can take 3x minus 2 out as a common factor. And then I multiply it back through by x squared minus 3. And this is now factored. X squared minus 3 comes close to difference of two squares, but 3 is not a square, so there's nothing else I need to do there. All right, the last one is 16x to the fourth minus 1. And this one is an example of multiple steps of, or another example of multiple steps of factoring. When you first look at it, it's difference of two squares, root 4x squared and 1. So it factors as 4x squared minus 1 times 4x squared plus 1. But notice here we have difference of two squares again. That root is 2x, that root is 1. This is not difference of two squares because of the plus sign. So when all is said and done and this factors out one more time, we're left with 2x minus 1, 2x plus 1. And then don't forget, whenever you refactor, you have to carry down what was remaining that wasn't factored again anyway. It doesn't just disappear. And so this would be the final answer. Again, make sure that you check your answers using the calculator by plugging in those numbers.